1, 2, and 4. This is how it's going to be. Okay. So some concept you have to explain. All right. And then you have to write your ADP specification, write ADP specification, and then you implement your. Okay, got it? So this is the flow of Vikram for chapter 1, 2, and 4. Alright, understand? Okay, so this question here is a non-collection ET. Alright, yours will be collection ET. Okay, it's gonna be okay.
697 997
Okay, so it's gonna be this. Alright, follow this up. Right? Okay. So you must know how to write ADT specification. Okay. You must know how to write ADT specification. Alright, then implementations. Okay. Okay. So this is how it's gonna be the question. Any question for the first part? Hannah? Now I'm going to jump to chapter 7. Okay. Now, chapter 7 might not have any copy papers. Okay. So do read through this. Okay. Chapter 7. Okay. Specific coding. Okay. This one coding. Okay. Here. Coding here, your implementation. Okay. Right. Then for this, also check in your practical classes. Right. You did practical, correct? Practical 7. Check coding from there. Okay. So you need to implement. Alright. Link. Now here you have to go through link and array. Both must go through. Okay. And for this chapter 5 here, it's a link implementation for list, stack, and queue, correct? Okay. For array, sorted array and sorted array list, sorted list lah. You must go through both. Okay. You must go through both. Okay. So your chapter on practical, go through carefully. Okay. So here gonna be your basic operation and go through in terms of add and remove. Okay, most important part here is that compared to the other list, okay, we can add, okay, we can add new entry, correct? Okay, you also can add in a position. Okay, this position event. Okay, then you'll have your new entry. Okay, this is for list. Alright, this is for list. Okay, now for sorted list, okay, for sorted list, we only have add. Okay, we only have add. Why is that? Why is that? Because it's sorted, isn't it? We have to find the correct location. So how do you determine here? Okay, we're going to use what we call compared to. Alright, so make sure in order to add, you need to use compared to. In order to remove, you need to compare to. In order to check contain, you have to use compared to. So those things you check lah. Alright. Go from here because this is sorted list. Okay. Alright. Okay. So how to write your compare to algorithm, okay, your compare to coding, yeah, okay. So if you take a look at it, let me just show you again. Right, this is our normal list to add, and this is how we add for list, okay. For array, the sorted array list, say sorted here. Adding here will be a bit different than this part here. Okay, see this? So that's the difference lah. Alright. So this is for array. Now you see remove. It's not in the sample code. It's from the practical task. Make sure you have the codes. Okay. And here, okay, how it can be prove it by using a while loop. Okay. How using compared to so this one also check. Okay. So add, remove, contain. Make sure you get it right. Okay. So the rest are not important. Now, okay. For instance, okay. Here we have make group. Correct. Now, let's say that you have to write this. Okay. Now, make group, you have to write the code. Say like they ask you to implement add or sorted list array. So this is the code. So one of the utility code is make group. Okay, make group is a very this much of code, but do you have to write it? Unless they specifically indicate, please include all the utility method, that means make group, then you write. Otherwise, don't write. Okay? Yeah? So don't waste time writing extra stuff. Okay? Because your marks is allocated for this line, this line, this line, this line, this, and this, and this. Okay? So maybe extra marks is maybe 1 mark here, 1 mark here, 4 marks. Here will be 5. And here you will have extra marks. So 1 for each of these conditions. Alright, especially if you use your compare to correctly. Okay, so you may have about 3 marks here, 3 to 4 marks here. Alright, so make group doesn't give you extra marks. Okay, utility. Of course, you need to write it in your main method, but you don't have to write the utility methods extra like this. Okay, understood? Okay, so don't waste time. Unless, of course, specifically it's indicated in the question, please include all the utility methods that you want. I hope I don't think so. Okay. Alright, so that is for sorting. Now again I have to reiterate sorting chapter number 4. Okay. And please go through the codes, okay, for both the array implementation and also the link implementation. Both go through. Okay, this one, and all the basic operation. Okay, all of it. Okay. Any questions? Okay. So, chapter 1, 2, and 4 study together. Okay. Chapter 7, you can study the entire thing. One chapter. When I say chapter 1, 2, and 4 study together means concept of all the ADT in the chapter 1. Chapter 2 tells you how to write the ADT specification. Chapter 4 tells you how to write the coding using array. So you study, across. Okay? Okay, what is that? Okay? Where do we use it? Okay? And then take a look at all the basic operations. write the in chapter 2. How to implement this particular operation. Alright, and okay. So now let's take a look at our chapter 6.
3诶3跟5不用了
Okay, chapter
3
6.
跟5不用了
Okay, chapter 6 is recursive. Okay, so chapter 6 recursive. What is recursive? Okay, remember recursive? Okay, now I do want to indicate here recursive we can use in sorting, we can use in searching. Alright, when we write sorting code, remember? Okay, we also can use it. Searching also we can use it. Alright. But it's not going to be in that area for your exam. Okay. So for exam purposes, okay, go through, okay, the concepts. What is your recursive means, okay, and also go through your box phrase. Okay, box phrase is very important. Okay. Now, recursive means, alright, when we call the method itself. So let's say I have some theory. Okay, I have some theory in N. Okay, so this is my method. Okay, hidden is now and it is written, for example. Then I have to call the method again. Alright, with n minus 1 for instance. Okay, so this is known as the recursive. Alright, then. Okay, so make sure how to write. Okay, how to write your recursive method. Okay, and also tracing. Okay, let's say tracing of our recursive method. Okay, so I just want to take a look at example here. All right. Okay. So when you draw a box phrase, okay, most important thing is that you must see the code. Okay. Take a look at the code. All right. So box phrase usually code will be given. Right. So let's see what code is this. Okay. What is the method? What is the recursive method here? What's the name of this method? Sum series, right? Okay. So we want to find out, okay, what is the value, okay, that if I were to insert here 10, what is the value? Okay, what is the results? Okay, so I have to go through this recursively in order to find out the results. Okay, so in this case, let's take a look at this one. Okay, let's say my sum series number is 3. Okay, for example. So n equal to 3, correct? Okay, so now my return value, this is my recursive call. Okay, so this is the recursive call, right? This is my argument here, recursive call. So I'm gonna write this here. Okay, so these are the information I have. All right, and also we stop? When we stop when n is less than 0, correct? Or n equals to 1, correct? Okay, so our stopping case, n equals to 1. Okay, let's put it this way. Correct, N? So these are the information I have. So how do I do box this? I know the last box is written when n equal to 1, written 1. Correct? This is my stop case. Last one, big case. Correct? Yeah? Okay. So I start, draw a box. Okay? Make sure you draw a box. Okay? The box has to be cascading like a waterfall. Alright? Okay? And then draw an arrow down. This is known as a recursive call. Okay? We are recursively calling the method again and again. So this is the recursive call. Now this is the return value. You must write some value, whatever value on example, must write. So this is just a skeleton, just telling you what it's supposed to be. Okay? Don't write, draw like this. This is a flowchart kind of thing. No. Okay? This one, no. Alright? So indicate the results. Okay? Indicate arrow down for the recursive call. Okay? So this is the return value, right? So whatever value we are returning. Okay? So now let's do this. Alright, so what to write inside the box? What to write inside the box? Okay, what to write? N equal to 3 and your recursive okay, your recursive call. Okay, so this is the line that we are returning, right? What are you returning? Okay, so this is what you have to write. So now n minus 1. So this one here will be 2. So now n is 2. What will happen if n is 1? You understand? What happens when n is 0? Okay, can or not? Alright? No problem? No issue, huh? Alright. So you have to write it, draw it, cascading, okay, like a waterfall type, okay? And then write the method. Okay, so 2 minus 1, you can write 2 minus 1 or you can just write 1. Sama juga. Okay, this one 1 over 1. Okay, 1 over 2. Okay, can? Yes? Any question? Any question here? Okay. Right, so your answer should be like this one. Alright, so here of course I don't know what happened. The line is not here. Like this. Alright, and okay, so that is for your chapter 6. Okay, chapter 6. If I'm not mistaken, Okay. Any questions? Anna? Okay, so chapter 1, 2, 3, 4, 5, 6, 7, done. Okay, let's take a look at chapter 8. Okay, chapter 8, chapter 9. Okay, 8. Okay, so here we have sorting, we have searching, okay, right. Chapter 9 is your binary. Okay. All right. So for sorting, okay, now you can ignore in terms of search. Okay. Now for sorting, of course, we have bubble sort. Okay, you have selection sort. You also have insertion sort. Okay, you have your quick sort and merge sort. Okay, yeah, no problem, huh? Okay, now basically, these two sort we can ignore it. So bubble selection, and insertion sort. So chapter 8 also I already reduced it for you. Okay, so for example, okay, let's say sorting. Let's say I have okay, let's say I have this value. For example, now, okay, now let's do bubble sort. How do you do a bubble sort? What do you do with bubble sort? Okay, what do you do with bubble sort? Right, largest to the end. How do we check? Adjacent value. Okay, adjacent. Okay, so now we will start. Okay, remember I told you don't write the whole thing in. Just end the pass, right? Okay, so for example, 4 and 5 is in correct order. Is in correct order? So 4 here. Okay, 5 and 10 correct order. Yes, 5. 10 and 12 correct order. Right. 12 and 2. So we swap. And then 12 and 31. Okay. So now we write like this, correct? And exam to indicate this is ordered. Draw a box. Okay. And then you must write and pass 1. Must write. Okay. All right. Next. Is it sorted? No. So because 2 is somewhere in the middle. So 4, 5, then 2, 10, 12, 31. Now which one is sorted? From 10 is it? No, because you want to remove 1, okay, element at a time. Okay. So 12 is now sorted. Okay. So again write enter pass 2. Okay, so here you must write and pass 2. Must write write in full. Alright, so next is for what do you do? 4, 2, 5, 10, 12, 3. So what is sorted from here? Do I do like this? Is this correct? No. Okay. Right. So make sure you know. Alright. Don't make silly mistake. Very easy mark from here. Okay. Now 2, 4, 5, 10, 12, 31. Sorted. Done. Finished. Okay. Done enough. Is it done? No. Why? Because we did swap. Remember? Swap. And because of that, we gotta run it one more time. No swap, no swap, no swap. Okay, here. There. Now it's fully sorted. Okay. Now for exam purposes, okay, right. Sorted using bubble sort. 2, 4, 5, 10. Okay, for exam purposes, just write that. Okay. Now you will lose mark here, most students, when they see like 2, 4, 5, 10, plus 31 of sorted already. Only one time. Okay. So here this marks here is about 2 marks. You will lose 2 marks. Okay. So be careful for bubble sort. Okay. Bubble sort, be careful. Okay. Now what if I don't write this? What if I don't write this? You're gonna lose marks or not? This I think for example, I can take that day only. Alright, we write this one. But if we don't write, also can. Right? Not lose marks, okay? As long as you are all the way here, okay, then it's okay. But this bagi cantik only. That's all. Okay? For example, exam purposes lang. Alright? Alright. Okay. Now, same value. Let's do alright. Same value. Selection sort. What is selection sort? Huh? Selection. Bubble sort, large at the end. Selection sort is the opposite. Smaller to the front. What do? How do you calculate? Direct swap. Okay? Direct swap. So now I'm going to take 4. What is the smallest number? 2. So 2, 4 here. Direct. Okay? So 5, 10, 12, and so which one is sorted now? 2 is sorted. So the next number from here. So what we have? 4. Okay? So 4 and 1. 10, 12, and what is sorted? The next one is this. Okay? What is the smallest number? 2, 4, 5, 10, 12, 31. This is sorted. Next is this. Okay, 10. 2, 4, 5, 10, 12, 31. So next is this. Are we done? No. again. 2, 4, 5, 10. Sorted, not sorted. 2 again. 2, 4, 5, 10, 12, and now also. Okay. Again, don't forget to write enter pass 1. Must write this. Enter pass 1, 2, 3. And it can sorted using selection. Okay, right. 2, 4, 5, 10. All right. 10. Okay. So now next is, let's say I want to have insertion sort. All right. Insertion sort. What we do? Insert in correct place. Correct. So we have 4, 5 is correct place. Okay. 10. Where do I insert? I got 4 and 5. Where do I insert? After 5, correct? So 4, 5, 10. There. Okay. Then 12. 4, 5, 10, 12. There. Okay. Now 2. 2, 5, 2, 4, 5, 10, 12. Insert correct place. Correct? Then 2, 4, 5, 10, 12, 31. Alright then. Okay, so insertion sort. This is how it works. Again, right. Okay, and the path 1 and the path 2 and so forth. Okay. And then for example purposes only, you just say sorted using insertion sort and write the sorted line. Okay, if you don't write that, not an issue, but okay. Alright. So these are nothing to sit down and read. Okay. That's okay already. Okay. Alright. So now let's take a look at chapter 9. Chapter 9. Okay. Remember, no coding on this, huh? No coding. Okay. So chapter 9, binary tree. Okay. Okay. Now binary tree, of course, we are talking about non-linear. Okay. This is a non-linear structure where we store our data in a hierarchical format or hierarchical structure. Okay? Yeah? Anna? Okay. So our exam area is gonna be binary search tree. Alright, binary search tree. Okay. So here you will have, at most you're gonna have children, 2 children. At most you will have your root. At most you will have, you can have a leaf node. Okay. No children. Okay. Know your root. You must know your right. Okay. Right child. And this is your left child. Right. Okay. So let's say let's see if I let's do question 18. Okay, so take a look at all these questions and all. All right, so we did this question before. If we didn't, yes, no, yeah, yes, yes. Let me do another one. Because if you already have the answer, good. All right, so let's do this question. You ready? All right, first of all, okay, for this, okay, you need to construct your tree, okay. You must know how to add into the tree. You must know how to remove items from the tree. You also must know your traversal. You have pre-order, in order, and also post order. Okay, and this one also will come with. Okay, all right. Okay, so now let's take a look at the question. Okay, let me just key in the value. Wait a minute. Right. All right. Okay, this one by the right. Huh? Okay, I guess that's it. Okay, so this is our pattern. Alright, so let's do this. Okay, now remember this enough. How to construct our binary search tree with in order and pre-order. Okay, now for your pre-order commercial, how we do the pre-order commercial? Can you guys still remember? Left first, root first. What is pre-order? Pre-order. Okay, pre-order is root, left, and right. Is that correct? Okay. Pre-order is root, left, and right. Okay. In order is left, right, and root. Left and root. Okay. So you must make sure you know this arrangement. As long as you know this arrangement, then it's okay. Now, in order, where is the root? Has to be in the middle. Okay. Pre-order root is in the front. So where's the root? Okay. What is it? 25. So in order to construct this is your root. Okay. Yeah. Understand? Okay. So now what is on my left root? What is on my left subtree? What is on my right subtree? How do I know? Okay. So we check on in order. So where's 25? 25 is here. 25 is here, correct? Yes or no? Whatever after 25 will be in the right, before 25 will be on the left. Okay? Okay? So now, my first left root. What should I have? Left. Now I check the first item in my pre-order after 25. What I have? 15. So this is my 15. Now 15 of course is on the left side. So this is my 15. Correct? So 15 here to the left and right. What are the numbers I have? Let me just write the numbers first. 4, 10, and 12. And here I have 18, 22, 24. Okay? Right enough. Yeah? Okay. So what should I have here and here? What should I have? Okay? So let's check the next number. On my pre-order, I have 10. Where's 10? Here, right? Okay? So this is my left, this is my right. 10, left, and okay? Got it? So I have 4, 12, done. 4 and 12 is done. Next number I have is 22. Where's 22? 22 is here. On the left I have 18. On the right I have 4. That's how I. Okay? Do you understand? Anything you don't understand here? And follow? 22 is there. Okay, next number is 18. Okay, 18 done. Next number is 24. 24 is done. Next is, what number is that? 50. Alright. So 50. Where's 50? On my in order, where's my 50? Where's 50? Here, right? So anything from here is my left, here is my right. So let's do 50. I remove this because I don't want to use this anymore. I remove it. 50. I have 31, 35, 44. Okay, so I have 31, 35, 44. 35, 44. Okay, on this side, I have 66, 70, and 90. Alright, okay? You understand that? But I don't know yet what I will have here. Okay, I cannot simply choose 35. No, I cannot just simply choose 35 and put here 35. Still have to take a look at what is my next number here. Alright, you understand? Okay, check nicely. 35 is here. That means, okay, I put the 5. How do I do it? Yeah. 50, 35. Allah. 44. And here, 70, 66, and last one is what? 90. Okay, got it? This is how you do. Alright? So I already created my tree. Okay. Now tips for exam. Okay. Now of course I know spacing here my spacing also tak betul lah. But what do you do when you draw a circle? Some student will just put like that. Okay, for example only I'm just doing this an example. Okay. Like that. Okay. Don't do like this. This is not a tree. Okay. Must do a circle. Okay. Do a circle. Okay. And another thing is that also you see the level. Okay. Make sure whatever node you have in the last level, they align like same line. Okay. Same line. Don't do like that. Okay. Don't do like this. Okay. Alright, okay. Now, when you have a child, one child only, okay, if it's left, make sure the line is towards the left. If it's a right child, make sure the line is towards the right, okay? Do not do like this. This is where I got middle child, okay? So it's left or right. So this one off, okay? Okay? Now, you see now already a bit packed, isn't it? You erase it and redraw again. Okay? Erase and redraw again. Okay? So, you gotta nicely erase, arrange again. Okay? Put it nicely. Okay? So, make sure this is like in a level. Okay? Not so. Alright, can Alright, so now let's see the add part. Okay, so now we want to add, okay, we want to add 75 remove 70. Okay. I want to add 75. I'm going to add first. Okay, where do I add 75? Okay. Start from the root. 70. Less or more? More. So check here. 70. Less or more? More. Then check here. This one is 50, correct? Was it 50? Was it 50? Okay, no. 50 is here. What number is that? 70. Yeah, 70. This is 70. Okay. Now 75. Where does it go? Less or more? More. Okay. So 90. So it becomes 75. Yeah. Correct? Yes or not? Okay. So for this question, you're going to draw this first. Draw the whole thing. Okay. Draw for adding. Okay. So below here. Okay. So you write binary. Earlier we already have answer for one, right? Okay. Next. Okay. What do you do? Let's do this. Okay. Let me cut this. I copy. All right. Now 75. Yeah. Is that correct? Okay. Now you have to redraw again. For exam purposes, you have to redraw. Say binary tree. What's the binary search tree?
他没有讲过 revision 了。
Okay. After adding 75. Okay. Okay. Now I want to remove. I want to remove 70. Okay. Now, how do you remove 70? Okay. Our question is to remove 70. Add 75. Remove 70. Okay. So now 70 got two children. LL. What that means? Left largest. Okay. Right smallest. So which one do you want to choose? Okay. Did they indicate which one to choose? Alright. So choose one. Okay. So I'm a bit lazy. I just erase this. So I don't want to redraw so much. 75. Okay. That's one. Okay. So right. Binary search tree after removing 7. Okay. Then done. Any questions? Okay. So next question here got sorting already. Okay. Sorting bubble start. Same thing lah. But it will submit it into, right? Okay. Now this is constructing tree from reversal order. Okay. want to do something without the traversal on. Okay. So if you have a tree, array like this, and they ask you to create a tree, what do you do? First one is the root. Okay. Then follow whether the second number is the lesser than the root or more than the root. Okay. Here don't have the adding and removing, but traversal. You guys know your traversal or not? I think definitely this thing's gonna come out. Do you know how to do traversal? All time? Okay? Anyone have any issue? Come back to me, yeah? I can go through with you. Okay? So do traversal. Based on traversal, do your bubble sort. Okay? Bubble sort, selection sort, insertion sort. Okay, because I search also I will do for you. Okay? Now last one. Okay? This one can. So to reiterate, to go back again, okay? Binary search tree, just go through the concept first, okay? No writing concepts question, okay? You just have to understand how binary tree works. The main area is you have to construct a tree from a value given, okay? Add and remove any value given. All right, you have to do traversal. Could be pre-ordered in order of post-order traversal. Okay. Plus, you will have sorting. Earlier, we already take a look at sorting. All right. We already looked some of the methods, some of the tricks also. Okay. So go through that. So, your question. All right. Here is get along. Okay, Ken? Alright, so then last one is the standalone. Okay, chapter 10. Okay. Alright, so let's take a look at chapter 10. Chapter 10, as I already mentioned, we're going to take a look at matching in specific. Alright, so concepts, terms must go through. Okay, okay, go through what is hashing, function, okay, for adding, okay, all right. So go through collision, right? So what are the collision methods we have? Open, go through, what is it, okay, how, okay. So go through your open addressing, all right, so your separate. All right, so here, all right, do pay attention on collision, all right. So in terms of adding data, okay. So you have your open, using open, okay, opening, you will have your linear, what else we have? Quadratic, double hashing, it also go through separate chaining, these are the things that we went through. Okay, so go through all this. Okay, now this is a very old paper. All right. So what is the hash table? So the concept we have to go through now. Right, now suppose we have the table size, so the hash table size 7. Right, then you're going to use the hash function, key modulus 7. So we're going to create a separate chaining to resolve our collision. So you need to show the hash table. Okay, after the following key is in, insert it. So first, what do you have to do?
Yeah, so many.
Let me write down the number.
Một lúc trước.
All right. Okay. Now, key modular 7. So, what is the answer? Can someone tell me? Okay. How to do? Bring a calculator to exam. Okay. Now, calculator. Learn how to do modular. Okay. I thought I remembered, then I forgot again. So please check. Okay. I want to find my data. Okay, give me a minute. Let me check.
Hả?
All right.
Bao
So
giờ?
94.
qua.
Okay,
Nhiều sân đi khăn luôn.
94 modular 7. Okay, what's the answer? 3. Okay. So must write like this. 47. 7. How much is it? 5, huh? Okay, let me know. 73 modular 7. 3. Correct, huh? Then this one. How much? 1 or what? Okay, how much? Tell me. This is 1. 5. This one? 5 also. Okay, done. Alright, so we already calculated the key. Okay, now question says, right, this one done already. Okay, now question says we have to use separate chaining. What is separate chaining? You guys remember still? Okay, separate chaining, what we do? What we do? Remember link, 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 link. This is separate chaining. Alright? So we're gonna do like this. Okay, ready? So we draw our table. Okay. So 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Alright, now ready? Okay. What time is it? Still got time, right? Now 94. Where do we supposed to store it? 3. Index 3 here. 3. So 3 is 9. Link this one, right? Now 47 and 5. 47. Alright, then we have 3. Also, we have 72. Okay? 15 and 1.
Hmm?
33 and
No, no.
5.
Hashtag go.
And also 50. Got it? Alright, yeah? Can I? So this is how you do your application. So this one you must write, and this one you must write. Okay? So that's the whole papers. So you can check on all the paper. Okay? Alright, let's take a look at this. Okay, by looking at this, what do you see? I have primary hash and secondary hash. This is the double hashing, right? And you have 2 hash functions. Okay, so here let me write. There we go. All right. Okay, so can you tell me what's the value here? 52. What is it? 8. All right. So use the calculator also can. All right. What's the value for 32? 10. This one. 6. This one. This one. This one. Okay. I take your answer. All right. So there you go. Okay. Mortgage. 52 modular 5. Now, the formula, plug in the value, put in the value. For example, you must write 52 modular 11. Don't just write it only. So write the whole formula in, okay, for your exam. Right, so what's the value? 3 here. Two, 3 also. Correct? 28, 25. Okay. 28, 3 is 2. This one, 0, 5. This one, 5 also, right? This one, 4. Okay, so for this one, back to write this way now. Okay, table size. Table size is 11. Already given to you. Table size 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, 52, where do I insert? Index 8. 52. 32, 10. 28, 6. 85, 85, 8, right? So cannot. So we have to take a look at the second hash, which is 5. So 1, 2, 3, 4, 5. So this is where 85 will go in. Okay? Right? You probe. Okay? 5 times. Now, 90 is 2 here. Cannot, right? So 90 is what? 90 is 5, right? So probe. 1, 2, 3, 4, 5. So 90 will be here. Alright? And then 61. 61 also cannot.
什么叫
How many? 4. 1,
hashing?
2, 3, 4. Got item here. What to do? Go 4. Okay, 1, 2, 3, 4. So 61 will be here. Alright, so this is the answer. Alright? Okay?
哎，等一下， 看你的歌。
Okay. Now, if the same thing, let's assuming this is the same thing, alright? 0, 1, 2, 3, 4, 5, 6, 7. Okay. Let's say I'm going to use a linear probe. K plus 1. Okay? Linear. Alright. Okay. So how are we going to do this? We're just going to take this value only now. Okay? We don't have double hashing. Just find it this two column. Okay. Alright? Okay? So let's try it. Okay? Now, 52, where does it go? 8. Alright? Now, 30. Yeah, correct. 6. Alright. Now, 85 is on 8. So I cannot insert it in 8. Plus 1, right? So 8 plus 1? 9. So 85 I put here. Correct? Okay, now 2. Where do I put 2? Oh, sorry. Plus 90 is on 2. Okay? Now 61. 6 here, right? So if I follow the linear, what do I do? 6 plus 1, 7. So I just move this the linear proof. Okay? Then this is the linear program. So let's say quadratic. So what we do? Okay? Alright, so you have k plus 1, k plus 2 power 2, k plus 3 power 2. Okay? And so if that's the case, alright, I just show you one 8. So 8 is 85. Alright? So what happened? 85. We have to do plus 1 first, correct? Okay, so we can put it here. Assuming there's something there, then you will have to go to k plus 4. Right? So you look 1, so plus 4 will be 1, 2, 3, 4. Alright? We just go like that. Alright. Now we have gone through the chapter 10. Okay, let me show you chapter 10. Questions format will be like the last semester. Format will be like this. Okay? Alright, this is how the format is going to be. No? Alright, so numbers gonna keep they will give a number. So it could be double hashing, it could be linear hashing, it could be separate chaining, it could be quadratic. Okay, all this. So I just opened the older paper, so they have a lot of questions on this. You can check. Okay, so any question? Okay, now, so for the last chapter, that's how the format's going to be entirely, hashing. All right, bring calculator for this. Okay, and then how to do modular. Okay, you can do it faster. All right, if you're good at mathematics, then it's fine. Okay, otherwise, you have to read it. Okay, but if you don't know, we just do a normal way of doing it. Let's say 52, and then you figure out. Okay, so this will be 4, correct? How many left? Okay, so that will be 10. So this number is the one that you have. The remainder is the modular one. Okay. All right. Now to go back again. Alright, chapter 1, 2, and 4, read together for your ADP, alright, specification and coding. Go through list, stack, and queue, alright, and go through array implementation, linked implementation of data. Alright, now chapter 6 and 7 study together, okay. Now 6 is recursive, trace box, go through, sorting, chapter 7, sorry, sorted list, go through array and linked implementation. Now chapter 8 and 9, sorting and binary tree. Last one is hashing. Okay? Any questions? Do you have any questions? Alright, exam is on the 10th. See you guys then. Thank you very much. Now if you have any questions, you can come back to me. Then I can go through it. Okay? Thank you. I'll see you guys. All the best for your exam. Right? I know I'll see you again in this class. Okay. Alright, so get the pass mark, okay? So all of you already got a very good mark.
내가
A very easy paper is done now. Okay? Alright, yes? Yeah, okay. Best of luck. Your attendance,